Hi there, it's good to see you again. So we're going to talk about naming and writing formulas for ionic things. Remember, ionic compounds have positive and negative charges. So we're going to write formulas, compounds, and we're going to use formulas just like in making a sauce you'd use a recipe. Same idea. So how are we going to name binary ionic compounds? Binary means two different elements put together, two different ions. And how do you write formulas for binary ionic compounds? So what's the name and how do you give them a formula? So gypsum's an ionic compound. We use it to, when you have a cast, in the old days they put gypsum and reinforce it with tape so you get a cast when you break an arm, leg. So binary compound is made of two elements and they're either, they can be ionic or molecular. So this is useful for covalent and for ionic compounds, so when we have two elements hooked together. So we just name the cation itself, just its regular name, and then we follow with the anion. So positive always comes first, then negative. It's left side of the periodic table, then right side. So like tin sulfide is used in toothpaste. It should be tin fluoride, sorry about that. Tin fluoride is used in toothpaste to prevent cavities. And this is the formula, and this is the name. It should be tin 2 fluoride, sorry about that, made a typo. And tin sulfide is used in porcelain fixtures and dishes. Here's another formula. So we're going to use, these all have two things in them, iron and oxygen, tin and sulfur, tin and fluorine. So these are two elements hooked together. That's called binary. It doesn't matter how many you have of each. It's just a binary if you have two different elements. So we write the symbol of the cation and then the anion, and then we add the subscripts for how many you have to balance out the charges. So for example, if I had copper 2 sulfide, you'll need a periodic table. Sulfur is in group 6, so it's going to have a -2 charge. Copper 2 means it's a +2, so you're going to have one copper, one sulfur to make the formula. So here we got copper has a +2, sulfur has a -2, so you just need 1 and 1 to make a neutral ionic compound. This one you have K is +1, nitrogen's -3. So to make this balance out, you're going to need 3 of these guys. So the easy way to do is this crisscross way. You just take this number here, put it there, take that number there, put it there. If you do that, almost always it works out perfectly, and you're going to have 3 potassiums balancing out 1 nitrogen. So this is called potassium nitride. You always name this guy just its regular name, and then you change this guy to an ide. So this crisscross method's useful for most things, but see, in this case it wouldn't be right. You'd put a 2 there and a 2 there. You'd have CQ2, S2. We always go lowest term, so if you find the situation where you have something like that, you always have to go to lowest terms so that's the smallest whole number ratios together. So crisscross works sometimes, but not always. So double check yourself when you're done. So you can try some of these. And then let's talk about when you have polyatomics. Remember, those are the ones I'm wanting you to memorize, okay? So we're going to write the cation, and then we're going to write the formula for the polyatomic, and we're going to balance the charges. So if I had calcium, which is a +2, nitrate, which is a minus, that's not written right, hold on. Nitrate should look like that, sorry. There should be NO3 down below and a minus sign there, so there's a typo there, sorry. Nitrate is NO3 -1. Calcium is a +2, so +2, oops, sorry, and a -1. I need 2 of these -1 guys to balance out that. Sorry about that typo, it's kind of messing us up. Let's try a different one. Okay, well, let's try this. Magnesium is a +2 ion. Hydroxide is a polyatomic. It has a -1 charge. So if I crisscross these numbers, I'm going to have a 2 over there and a 1 over there, and I'm going to get magnesium hydroxide. So +2, -2, that balances out. Let's look at this one. K, potassium's group 1 plus 1. Sulfate is -2 for the whole polyatomic. So if I crisscross these numbers, I get K2 SO4. So I need 2 potassiums to balance out the 1 sulfate. So there's some more practice ones. You can try those. And so we write the cation first, and then we write the anion second. Here's sodium hypochlorite. We use it in pools. It's good for killing all kinds of viruses and bacteria. It's got a sodium and a hypochlorite, and that is a plus and a minus, so they balance out. So it's NaClO. Let's see how you guys do. Alright, what do you think this guy would be called? This guy's a transition metal, so that's a clue that you need something special when you do this naming. It's those B guys in the center of the periodic table. So see what you can do on that one. So this would be chromium 3 chloride, because chromium is a +3 and balances out with 3 negatives. Chlorine is -1, so you need 3 of those negatives to make it work. Okay, what's the formula here? Strontium and nitrogen. So look at the periodic table. Figure out what you think, how they would go together. This is a binary, 2 elements together. So we're going to use the I ending. So this one is strontium is +2 and nitrogen is -3. So if you crisscross those numbers, you get that formula. Last question. Which of these is named correctly? So this one is sodium acetate. This is a big polyatomic that we have to memorize. This has a -1 charge. Sodium is a +1 charge. So I hope this gives you an introduction to naming, and you'll have a lot of practice with this. I have practice for you guys, and we'll get really good at this. Okay, I'll talk to you soon. Bye-bye.